All right, so today we're diving deep, into the Dartmouth Conference of 1956.
Yeah.
And this is really the event that kicked off the AI revolution as we know it.
It is.
So picture this, it's summer.
Mm-hmm.
A group of brilliant minds, they all gather at Dartmouth College.
Mm-hmm.
And what happens? Well, it's kind of a story of spectacular ambition, but also spectacular misfires.
It really is. It's a fascinating paradox.
Yeah.
The Dartmouth Conference is hailed as this birthplace of AI.
Right.
But if you look closely, it was kind of a mess.
Wow.
A chaotic mess.
Okay.
It's almost like the seeds of AI were sown in this fertile ground. But nobody really knew how to tend to the garden properly just yet.
I am intrigued already.
Yeah.
So we've got these geniuses, we've got this groundbreaking concept, and we've got chaos.
That's right.
This is like giving me serious what could have been vibes.
Mm-hmm.
So where do we even begin with this story?
Well, we have to start with the visionary behind it all.
Okay.
John McCarthy,
Okay.
a young mathematician with this, can machines solve problems?
Yep.
Can they understand language?
Mm-hmm.
Can they even learn and improve themselves?
Oh, wow.
And keep in mind, this was 1956.
Yeah.
Computers were still in their infancy.
Right.
And the idea of artificial intelligence was truly radical.
It's mind-blowing to think that these ideas were already swirling around back then.
Yeah, it is.
Okay, so we've got the vision, we've got the brilliant minds.
Right.
Where's the flop come in?
Oh, well, here's the thing.
Okay.
Despite McCarthy's hopes for 8 weeks of intense collaboration,
Yeah.
only 3 people actually attended the full conference.
What?
Yeah.
You're telling me out of all those brilliant minds,
Yeah,
only 3 stuck it out for the entire duration?
that's right.
Wow. That's wild.
Yeah.
What happened?
It seems like there was a bit of a disconnect between the grand vision and the reality of academic schedules and commitments.
Okay.
Most attendees came for just a couple of days,
Really?
popping in and out between other obligations.
Wow. Okay, so maybe not the deep dive into collaboration that
Right.
McCarthy had hoped for.
Exactly.
Is that like the main reason the conference is considered a flop?
It was a significant factor.
Oh.
Think about it. You have all these brilliant minds, each with their own ideas
Right.
and areas of expertise,
Yeah.
but they're barely scratching the surface of what they could achieve together because they just don't have the time
Right.
to really, dig in and hash things out.
It's like a potluck where everybody brings amazing ingredients,
Yeah,
but nobody actually stays long enough to cook a meal together.
exactly.
Yeah.
And it's hard not to wonder what might have emerged if they'd had more time to connect,
Right.
to challenge each other's assumptions, and to
Uh-huh.
truly collaborate.
Yeah, I'm already sensing some serious what-if moments here. Are there any specific examples of those missed connections that stand out?
Well, John McCarthy himself later lamented the absence of 2 figures
Okay.
who sadly passed away before the conference: Alan Turing and John von Neumann.
Those are huge names in the early computing world.
They are.
What kind of impact might their presence have had on the conference?
Well, Turing,
Yeah.
with his groundbreaking work on computation and the theoretical foundations of AI,
Right.
and von Neumann with his expertise in computer architecture and game theory,
Yep.
their contributions could have been monumental.
Yeah.
It's so tantalizing to imagine the brainstorming sessions, the debates,
Right.
the potential breakthroughs that might have emerged
Right.
if they had been part of the mix.
Okay. I am officially hooked on this alternate history.
Yeah.
But let's get back to the reality of the Dartmouth Conference.
Right.
Even with these misconnections, surely something came out of it right.
Yeah.
It's considered the birth of AI, after all.
That's true. Yeah, you're absolutely right. Despite its chaotic nature, the Dartmouth Conference did manage to plant some incredibly important seeds.
Right.
For one, it firmly established the term artificial intelligence, giving this emerging field a name and a sense of identity.
So even if they didn't quite manage to cook that metaphorical meal,
Right.
they at least decided on the name of the dish,
Exactly.
which in hindsight is pretty significant.
Yeah, absolutely. And they did more than just come up with a catchy name.
Okay.
The conference helped to galvanize a whole generation of researchers,
Okay.
inspiring them to tackle the challenges of creating intelligent machines.
Okay, so we're starting to see those ripple effects.
Yeah.
But what about the actual research that emerged from Dartmouth?
Right.
What specific approaches to AI did they focus on?
Well, the dominant approach that emerged from the conference, and one that shaped AI research for decades to come, was known as symbolic AI.
Symbolic AI.
Yeah.
Could you break that down for us a bit?
Sure.
What's the core idea behind it?
Essentially, symbolic AI is all about representing human knowledge and reasoning through symbols and rules that computers can understand and manipulate.
Okay.
It's like trying to create a detailed instruction manual for intelligence, breaking down complex tasks into a series of logical steps.
So if you want a computer to, say, understand a sentence or solve a math problem,
Right.
you'd need to feed it a set of symbols and rules that represent the grammar of the language,
Yeah.
or the principles of mathematics.
Exactly. And this approach had some early successes.
Okay.
Remember Alan Newell and Herbert Simon from our all-star lineup?
Of course, two of the big brains who actually managed to attend the entire conference.
That's right. Well, they went on to develop a program called the General Problem Solver,
Okay.
or GPS for short.
General problem solver.
Yeah.
That sounds incredibly ambitious. What was it designed to do?
As the name suggests, it was meant to mimic human problem-solving abilities.
Okay.
The idea was that GPS could be given any problem within a certain domain, and it would use its knowledge of rules and logic to come up with a solution.
So they were basically trying to create a one-size-fits-all solution machine.
Yeah, pretty much.
Did it work? Was it able to solve all sorts of problems?
Well, not quite. While GPS was groundbreaking for its time, it also highlighted the inherent limitations of symbolic AI.
Okay.
It turned out that codifying all of human intelligence into a neat set of rules was a lot more challenging than initially anticipated.
That makes sense. The world is messy and unpredictable.
Right.
And human intelligence involves a lot more than just following a set of pre-programmed rules.
Precisely, GPS was good at solving certain types of logical puzzles,
Okay.
but it struggled with tasks that required common sense intuition or the ability to learn from experience.
Right.
For example, imagine you're trying to teach a computer to recognize a cat in a picture using symbolic AI.
Okay, I'm picturing a very confused computer
Yeah.
trying to process a bunch of pixels.
Exactly. You'd have to define a set of rules that describe all the visual features of a cat.
Okay.
Its shape, its size, its fur, its whiskers, and account for all the possible variations.
That sounds like a logistical nightmare.
It is.
You'd need a rule for every possible breed,
Right.
every possible pose,
Yeah.
every lighting condition.
Exactly. And even then, it wouldn't be able to handle new or unexpected situations.
Right.
What if the cat is partially hidden behind a chair?
Oh, yeah.
Or what if it's a breed of cat the computer has never seen before?
Right.
Symbolic AI, with its reliance on predefined rules, simply doesn't have the flexibility to handle that kind of complexity.
So it's like trying to fit the entire world into a neatly organized filing cabinet.
Yeah.
You might be able to categorize some things,
Right.
but eventually you're going to run out of drawers.
That's a great analogy. And this limitation of symbolic AI would eventually lead to a period of disillusionment and reduced funding in the field, sometimes referred to as an AI winter.
So what happened next?
Yeah.
Did AI research just grind to a halt? Well, it didn't completely stop, but things definitely slowed down for a while.
Yeah.
Researchers started to realize that maybe symbolic AI wasn't the silver bullet
Right.
that they'd hoped for.
Yeah.
But thankfully, the story doesn't end there.
No, it doesn't.
Yeah.
The quest for intelligent machines continued, and while symbolic AI hit a roadblock,
Right.
the seeds of other approaches were already planted even back at that chaotic Dartmouth conference.
Wait, really?
Yeah.
So even amidst the flop and the focus on symbolic AI,
Mm-hmm.
there were hints of other paths forward.
There were. In fact, McCarthy's original proposal for the conference mentioned something called neural networks.
Neural networks.
Mhm.
Oh, yeah. I feel like I've heard that term everywhere lately,
Right.
especially with all the buzz about those new AI language models.
Exactly.
Are those the same neural networks they were talking about back in 1956?
They are.
Wow.
Yeah. The basic idea of neural networks is to model artificial intelligence on the structure of the human brain,
Oh, okay.
creating systems that can learn and adapt from data
Okay.
rather than relying on pre-programmed rules.
So instead of giving the computer a step-by-step instruction manual,
Right.
you're essentially giving it a brain-like structure
Yeah.
and letting it figure things out on its own.
That's the gist of it, of course. Back in 1956, the idea of neural networks was pretty far-fetched.
Right.
They simply didn't have the computational power or the data sets needed to make these systems work effectively.
Okay.
It's fascinating to think what might have happened if they'd focused more on neural networks back then.
Yeah, it makes you wonder if we could have avoided those AI winters altogether.
Yeah.
Or maybe we would have ended up with a totally different AI landscape today.
It's impossible to know for sure, But it's always intriguing to explore those what-if scenarios.
Right.
They remind us that the path of innovation is rarely a straight line,
Yeah.
and that sometimes even seemingly failed events can have a profound impact in the long run.
It's like those early explorers who set out to find a new route to India,
Right.
but ended up discovering America instead.
Exactly.
Sometimes the greatest discoveries are the ones we weren't even looking for.
That's right. And in the case of AI, those early explorations of neural networks, even if they weren't immediately successful, laid the groundwork for later breakthroughs.
So when did neural networks finally have their moment in the spotlight?
Yeah.
When did they go from a fringe idea
Mm-hmm.
to the driving force behind AI that they are today?
Well, it was a gradual process with periods of both progress and stagnation.
Okay.
But things really started to accelerate in the late 1980s and 1990s with advances in computing power
Okay.
and the development of new learning algorithms.
And then in the 2010s, things really exploded
Yeah.
with the rise of deep learning, right?
You got it. Deep learning is essentially neural networks on a much larger and more sophisticated scale.
Okay.
These networks have many layers, allowing them to process information in a much more complex and nuanced way.
And this is what's powering all those AI applications we see today.
Yeah.
Everything from self-driving cars
Mm-hmm.
to personalized recommendations on our favorite streaming services.
Exactly. Deep learning has revolutionized AI-enabling breakthroughs in areas where symbolic AI had struggled, like image recognition,
Right.
natural language processing, and even complex decision-making.
It's amazing to think that something that was barely a blip on the radar back in 1956 has now become such a powerful force in our lives.
It really is. It really speaks to the importance of long-term thinking and continued exploration, even when faced with setbacks.
Right.
You know, the seeds of innovation can sometimes take decades to truly blossom.
So looking back at the Dartmouth conference, it's clear that it wasn't just about immediate successes or failures.
Right.
It was about sparking a movement, planting ideas, and inspiring a generation of researchers to grapple with the profound questions of artificial intelligence.
And that grappling continues today, perhaps even more urgently than ever, as AI becomes more powerful and pervasive.
Right.
It's crucial to think about its ethical implications, its potential impact on society, and the ways in which we can shape its development for the benefit of all humankind.
Absolutely. That's a really powerful thought to leave our listeners with. So to recap our deep dive,
Yeah.
we started with a seemingly failed conference that was actually a crucial catalyst. We explored the rise and fall of symbolic AI
Mm-hmm.
and the eventual triumph of neural networks and deep learning.
That's right.
And throughout it all, we saw the importance of persistence exploration and the willingness to challenge assumptions.
Couldn't have said it better myself.
So as we move forward into an increasingly AI-driven future,
Yeah.
those qualities will be more important than ever. It's up
Yeah.
to all of us to learn from the past,
Right.
to engage in thoughtful discussions, and to work towards ensuring that AI is a force for good in the world.
Well said.
Well, on that note, we'll wrap up this deep dive into the fascinating and complex history of artificial intelligence. Until next time, keep those brains buzzing.